Great. You're welcome to today's lesson. You want to get your notebooks. Let's go through as usual. Get your notebook, get your calculator. If you know you're in any atmosphere or environment that is going to prevent you from focusing, just follow this. You want to be away from every form of distractions, okay? So make sure you have your notebook, your calculator, your pen, pencil. We're going to go through today's lesson. Now, this week is our evaluation week, so we're going to do an assessment. If you're already freaked out about assessments, don't worry about it. It's basically everything we've done so far. If you just want to do good in the assessment, just go and watch all the videos we've done this semester. Or I can post my lecture notes. I'm going to post my lecture notes up to today's class. I'm going to post it. And if you can just go through the slides, you should be ready for the test, for the assessment. And you're going to do it in groups. So get ready to contribute in your group. It's going to be a lot of work and you have to share the work and do it together. If you're not ready to contribute, you're going to delay your group. So please prepare yourself. The guideline for the assessment is going to be available on Wednesday. It's already there, but on Wednesday it will be unlocked so that you can access it. Let me know if you have any feedback on that, okay? So we're looking at let's start with our bell ringer for today. Everybody, I want you to look at this question and give me what you think. Or write down what you think. What is the relationship between pressure and volume? What is the relationship between pressure and volume? Yeah, so that's what we're going to be. This is just to open us up to what we're going to do today. Think about it. We said that pressure is equal to force over area. So that if a gas is occupying more area, if I keep this force constant and I'm increasing the area, meaning the gas is expanding and occupying more area, we're saying that what is going to happen to the pressure? Looking at this mathematical equation, it means that when this area goes up, the pressure is supposed to go down because they are inversely related. Inversely related. Okay, they're inversely related. So I want you to think about it in that way. So basically, from this mathematical equation, remember that we said volume is equals to just length times breadth times height, which we can also say is area times height. What that means is that your area is very much related to your volume. So it's in effect, if your volume increases, your pressure reduces because they are inversely proportional. We're going to do more of that. Okay, we're going to learn more of that. So that is what we're going to do today, and I want you to think about it. Okay, great. That's what we're going to do today. So let's get ready to go into that. Good. So today we're going to be looking at the following on your screen. Please give me a second. So great. So sorry about that. So we're saying that today we're going to go over. Remember, we started last time with ideal gas law. We said that the general combined ideal gas law is PV equals nRT. This is the general law. But this general ideal gas law, it's as a result of several laws that have been combined. Okay. So we want to take the individual laws that have been combined, look at them and how they were they came about, and that will inform how the general ideal gas law works. Okay, so we're going to look at Boyles law, go through Boyles law, understand it very well. Now try and solve some questions. Then we're going to look at the next law. It's called Gay-Lussac law. Some people call it Amonton's law. So two different people are uh, recognized when it comes to this particular law. One person proposed the principle of the law first. Now, the next person later provided more evidence and more work to support the law. Do you get it? Okay, okay. Great, 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 great. So that's what we're looking at. So we're going to look at Gay-Lussac. So some people call it Gay-Lussac law. Other people call it Amonton's law. We're going to try and solve more questions. Then we're going to look at the combined form of ideal gas law. This is the agenda, but I don't think we can finish all of this in this class. If we don't finish, we're going to continue wherever we left off, whenever we resume. Okay, so don't worry about that. So hopefully you're ready to get into this. Great, so we want to start with Boyle's law. We want to start with Boyle's law. The relationship between pressure or volume and pressure. Okay, so we're looking at if I have an amount of gas, I want to pay attention an amount of gas. I don't change the temperature, means that I keep the temperature constant. So let's say if the temperature is 100, I leave it at 100. Let's say I have a gas at 100 Fahrenheit. That's just an example, right? What will be the relationship if I keep the temperature of the gas constant? What will be the relationship between the volume and the pressure? Okay, that's what we're talking about. So the first person to do any work on this is a gentleman by name, a philosopher called Robert Boyle, and that was 300 years ago. You see, so it's interesting that principles will work regardless of the time. If the principle is true, no matter the year, it's supposed to work. Okay, so truth is truth no matter where you stand in the world. If something is true and it's supposed to be true, it's true everywhere else. Okay, so science is trying to find truth. And so this gentleman by the name Robert Ball sat down and made observations and came up with a principle that governs the pressure of a gas with respect to the volume. If his principle, now his principle became a law. If you remember when we were doing chemistry, we said that based on the scientific method, people come up with there's a problem, people try to solve the problem. To be able to solve the problem, you analyze the problem, you form something that is called a hypothesis. I don't know if you remember that. You form a hypothesis. Now, your hypothesis has to be tested through experiment, more observations. Then, if your hypothesis is true, then you can come up with a theory. Okay. If your theory is tested over and over again and it produces effect, it can graduate and now it can be accepted as a law. This is just a summarized version of scientific method. We did this when we were beginning. So this guy called Ball, his concept graduated to become a law. Once it's become a law, it means it's valid. Okay, so in all of science, we are saying that the volume of a given amount of gas at a constant temperature is inversely proportional to the pressure which is it is measured. So think about it. We're saying that if I have gas at a constant temperature, means that the temperature is not changing. Okay. The analysis here is that I have a gas. I keep the gas at a constant temperature. I don't change the temperature. We're saying that the pressure of that gas, it's going to be inversely proportional to the volume, or the volume of the gas is going to be inversely proportional to the pressure. What does that mean? I want us to think about these two things. So remember, we said that volume is the space occupied by matter, right? So the amount of space that the gas is occupying is what is the volume. We know the pressure is what? The force exerted over a certain amount of area. Okay. Now we are seeing that the relationship between them is inversely proportional. Now that is why I want us to pay attention to. In our previous two classes, we started talking about proportionality. Okay. When we say something is inversely, sorry, let's start. When we say something is directly proportional, it means that when A increases, B also increases. So we say that they are directly proportional. It means that A is directly proportional to B. That's what it means. It means that if I increase the value of A, B is also going to increase. The same way, if I decrease the value of A, in effect, B is also supposed to decrease. That's the meaning of that's the meaning of directly proportional. Now, on the other hand, when we say something is inversely proportional, we are saying that when A increases, B rather decreases. Okay, then we say that what? In this case, we're saying that they are inversely proportional. So we call this directly proportional. Now, when you say something is inversely proportional, there's a way to write it. So that's what we're going to look at. Okay. It's important to be able to understand this. So so let me put this so that we have two screens. So on the left hand side, we are looking at directly proportional. Now let's look at the right hand side. When A is increasing, B is decreasing. So we say they are inversely proportional. We're going to write this as A is inversely proportional to B. This is how we're going to write it. Okay, so this is the first thing I want you to know, how to write proportionality. Okay, so that's the first thing we want to establish. So to write that A is increasing whilst B is decreasing, we write it this way. A is inversely proportional to B. Now, so this is just a proportionality statement. Now, to be able to change this proportionality statement into an equation, we need to introduce something called a constant. Okay, so we're going to try and change this into an equation. We're going to have A. I want to write an equation, so A should be equal to, then I bring my constant. My constant, let's say constant is K. So the constant is K multiplied by 1 over B. So right now we just converted this into an equation. Okay. In the same way, if I wanted to convert what I had on the left hand side here, it would have been A equals what? What do you think is going to be? K multiplied by B. That's how to write it in an equation. So this is the first thing we are learning here. I need you to pay attention to this. Okay. I need to pay attention to this. This is important because it's going to influence what we just spoke about. So Boyle's law states that what? The volume of a gas at a constant temperature is inversely proportional to pressure. So now I want to write Boyle's law. Let's write it together. So I'm going to write Boyle's law. So Boyle is saying that let me write B to stand for Boyle's law. Okay. So Boyle is saying that the volume is inversely proportional to the pressure. That's what Boyle is saying, right? Volume is inversely proportional to pressure. We can write it as V equals what? 1 over P if you bring the constant K, okay? Which I can write also as what? V equals K over P, okay? So this is how you can write Boyle's law. That volume is equal to what? K over P. That's one way to write Boyle's law. We're going to talk more about Boyle's law as we go to the next screen. Okay, great, great, great. So now I want you to take a minute and read what you see on the screen. It's just going to explain what we just spoke about more. So everybody, just take a minute, read what you see on the screen. Okay, so we want to look at it together. So we're saying that we're still looking at Boyle's law. So we want to analyze what we just spoke about. So let's write this together. So mathematically, we write Boyle's law as V should be equal to K over P, or we can write it the other way. P is equal to K over V. Okay. What this means is that now based on this, we're saying that pressure is inversely proportional to what? To volume. Means that if my pressure increases, my volume decreases. If my volume increases, my pressure decreases. From this, we can write that PV equals, from this, we can write that PV equals K. PV equals K. Okay. Now we said K is a constant. What that means is that what this means is that when I multiply pressure by volume, I'm going to get a constant. So it means that for any amount of gas, volume of gas, and a specific amount of pressure that corresponds to that volume at a particular temperature is a constant. So let's say I have gas A. Gas A has a pressure A when it's occupying a volume A at a certain temperature. If I multiply the pressure by the volume, I'm supposed to get a constant. If I have gas B with a certain pressure and the volume of that gas B at a certain temperature, if I multiply the pressure and the volume, I'm still going to get a constant K. Okay? So what this means is that in effect, I can write that pressure of gas A occupying a volume A can be equal to pressure for gas B multiplied by a volume B. Okay, so this is one of the very useful equations we can derive from Boyles law. You're going to see how useful it is very soon. Okay, but this is just the mathematical side of what we've been talking about so far. Now, I asked you to read this on your own. Hopefully you did. Okay, so let's try and break this down. Let's try and break this down. If we partially fill an airtight syringe with air, the syringe contains, so we're reading this, we're analyzing this statement. Okay, so if we partially fill an airtight syringe with air, the syringe contains a specific amount of air at a constant temperature. Let's say 25 degrees Celsius. Good. If we slowly push in the plunger while keeping the temperature constant, the gas in the syringe is compressed into a smaller volume and it increases the pressure. Okay. What we're just trying to say is what we're just trying to say is that imagine I have this space. Okay, let's say this is something that this is like a squishy ball and I have gases inside this squishy ball. This is there's pressure inside this system because there's gas filling it. The moment I begin to squish this ball, I am reducing the volume. Initially, this was the volume. If I continue to apply this pressure now, let's say the squishy ball now looks like this. Okay. What I just did is that I just reduced the volume. But we are saying, imagine that I just reduced the volume, but the gas inside there is still the same amount of gas, but I'm reducing the volume, or the same amount of pressure initially is the same amount of pressure. So let's say this is A, this is B. Because I am reducing the space that the same amount of gas was occupying, I am going to cause the pressure in the system to increase. Okay, and that is basically what Boyle's law came about. Okay, so we can look at this, or we can represent this concept on a graph. So we're going to look at all these graphs. This is graph A, this is graph B. Okay, and I want you to look at this image carefully. Look at this image too. So in this system, they have a setup where so we have this setup here where we are measuring the pressure. So as you can see, we have this is measuring pressure, and this is volume. Okay, so we are saying that when I reduce my volume, I increase my pressure because they are inversely proportional. Okay, so keep that in mind. So we're going to look at this here. Let's read this before we move on. Decreasing the volume of a contained gas will increase its pressure, and increasing its volume will decrease its pressure. In fact, if the volume increases by a certain factor, the pressure decreases by the same factor, and vice versa. So we're trying to say that it is proportional. So anytime we talk about proportions, we're saying that the amount with which it will increase is the same, or the amount with which it will decrease is the same. So what we are saying is that, let's say, we're saying that if I decrease this by 5, okay, then I'm going to increase the pressure to by a factor of 5, like a multiplier. So let's say if I reduce this by 2, this is going to increase also by 2. That's what we're trying to see. So now let's look at our graphs. Okay. So if you don't know what this is just a graph. Okay. If you in your math class you learned how to represent data. Okay. There are several ways of representing data. You can represent data on a Venn diagram. You can represent data on a chart. You can also represent data on a graph. So in A we have a graph. So let's look at A. Now, this axis, so on this graph, there are two axes. We have the x-axis and we have the y-axis. Okay. If you don't remember your math class, I'm going to try and help you. So this is your y-axis and this is your x-axis. We are saying that your y-axis here is your pressure and your x-axis here is your volume. So now I want you to look at the relationship. What is the relationship between pressure and volume? How do we know the relationship? Now, look at the graph. First of all, to know the relationship between two quantities on a graph, look at the shape that the graph is producing. So we plot points. Okay. So what they did here in A is that they took a graph, they took points. So you see here, I want everybody to look here. You see 5 and 39. What that means is that they took a value of volume. Okay, always you plot your x first, then the y. So they took they took they took a value of volume, it was 5. Then they took a value for the pressure, it was 39. So let's say somewhere here. And that's how they got to this point. Okay. Then the next thing was that they took a volume of 10. Then they took a pressure of 19.5. So somewhere here. And that's how they got the point. So we plot the points. So it means that they were presented with the data. Okay. So there was a data of pressure and volume. So let's say they did an experiment, they measured gases, the pressure and the volume, and they put it on a graph. And they realized that as the volume was increasing and the pressure was also decreasing. How do I know that? Look at it. When the volume is 5, we had a pressure of, let's say, 39. That is what we have here. Now, when the volume was 10, we had a pressure of 19.5. You see, so it's decreasing. From 39, it's going to 19.5, whilst this is increasing from 5 to 10. So that is why the shape of our graph, it's like a hyperbola. Okay, it's like hyperbola. Okay, that is to show you an inversely re proportional relationship. Okay, what that means is that the graph is telling you that the relationship between your pressure and the volume is not a straight line. If it was a direct relationship, it would just be a straight line. Okay, so that when your pressure increases, your volume increases. That's a straight line. But in this case, we don't have a straight line because the relationship between pressure and volume is not a straight line. It's like a hyperbola. So it's there. If it was a direct relationship, it would have just been a straight line like this. But in our case, it's not a straight line because it's not a direct relationship. One is increasing, but one is decreasing. So we should have a graph that looks like a hyperbola. So that's what we were seeing, something like this. So half of this is like what we were looking at as our relationship. Okay, so that's the relationship you're looking at. Now, there's a problem with this graph. The only problem with this graph is that you cannot measure smaller, smaller quantities. Let's say, what if I want to measure a volume of 0.2? As you can see, the graph cannot cater for 0.2. It starts from 0, then it goes to 5, 10, 15. It's increasing by multiples of 5. Can you see that? From 0 to 5, it's increasing by multiples of 5. So let's look at it. Look, it's increasing by multiples of 5. It starts from 0, then it goes to 5, 10, 15. The same here, 5, 10, 15. So this graph can represent values that are big. A problem is that if you have a smaller value, you cannot represent your smaller value here. Okay, so there's another way we can represent the values. Okay, to be able to represent the values, we have to now establish the inverse relationship. So remember here, we just took the pressure, we took the volume, and we plotted it, and we have this hyperbola. Another way to represent the same data is to just take, remember we said that the relationship between pressure and volume is 1 over the other. Okay, so the volume is equal to the constant divided by the pressure. Okay, so we can take the volume and represent the volume here and divide the pressure by 1. So that's what they did here. As you can see here, they took the pressure. It's just like this. Our volume here. So the volume here is the x values. The y value is 1 over the pressure. That's what they did here. 1 over the pressure. So that then we can have very small values. Okay, so if you want to represent smaller quantities of pressure and volume on a graph, you just use the volume and the inverse of the pressure. Okay, so that is what we are looking at, how to represent the data on a graph. Good, 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 good. Great. If you have any question, you can send them to me. But I want you to now pay attention carefully and look at how I read the graph. If you didn't get it, I want you just, you can go back and watch this video just to understand that, because we're going to solve some questions after this. Okay. Okay, so let's go on. So we're going to try. Good, good, good. So this is just another overview of the mass we just went through. Okay, so we are establishing this. We are saying that the relationship between the pressure and the volume is that when pressure, let's go over again, when pressure is increasing, volume is what? Decreasing. We call that pressure is inversely proportional to volume. You can write this the other way. Volume is inversely proportional to pressure. It's saying the same thing. If you want to write this as, if you want to write it as an equation, I said you need to introduce what? Constant. The only way to turn this proportionality statement into an equation, if you want to bring an equal to, then you have to bring a constant k. So let's say our k is just standing for the constant. A constant can be w or v. You can't put v because there's already v here. So your constant can be whatever you want it to be. So this is the relationship. This is also the same as p equals k v. Okay, you can, it's the same thing. If you want to write it the other way, it could be v, sorry, it could be v equals k divided by 1 over p. So that v now equals k p. Now we said that k is a constant. That's what I want you to remember. This k is a constant, means that it doesn't change. So what that means is that, let's say I want k to be the subject here. Remember we said p equals k v. Then k now can be equal to p v, p times v. So we are saying that p times v is a constant. What that means is that if I take a pressure of a particular gas at a certain amount, at a constant temperature and I multiply them, I'm going to get a constant. If I took a different gas, so let's say this is pressure 1, volume 1, standing for a gas 1. If I took gas 2 and I multiply the pressure of gas 2 at a certain volume, at a constant temperature, I'm still going to get a constant K. So then I can equate K to be equal to K because it's the same thing. Then if this is true, then I can say that P1 V1 can be equal to P2 V2. And this is the biggest takeaway from Boyles law. We're going to use this formula to help us solve a lot of things. Provided we have what K. So all this is based on the fact that we introduced a proportionality constant here, which is called K. Okay. Now your K is going to be a term of what? Pressure and volume. Okay. So your K is a term of pressure and volume. So let's say my pressure was in atm. Let's say my pressure was in atm, and let's say my volume was in ml. So then my K is going to be, because it's pressure multiplying volume, it's going to be atm dot ml. This is just an example. Okay. Okay. That's just an example for the unit of K. So this is just going to be the unit for K in this situation. Okay. Wait, so I want you to write this formula. Now this is the main formula you want to write down. Or you can write how we proved K. Okay, for Boyles law. You can write this down. Then we're going to move on. Okay. Great, 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 great. So I'm gonna ask you here on your own. Prove how P1 V1 is equal to P2 V2. This is the question I'm gonna ask you to prove. Prove, prove that P1 V1 is equal to P2 V2 according to Boyles law. You're going to prove this on your own. Prove this in your note on your own, okay? To help you understand this. So we're going to try and solve this question. Are you ready? Let's try this together. So we want to read this carefully. The sample of a gas in figure 9.13. So figure 9.13, we're just looking at, are you looking at this? We're looking at this. This is our figure 9.13. We're saying that it has a volume of 15 ml. Pay attention. And a pressure of 13 psi. So we are saying that a certain gas. So anytime you have a question, write down everything the question is telling you. Okay. So let's solve this together. Solution. There's a certain gas. So let's say I'm going to call gas A. Okay. Gas A has volume. What is the volume? 15 ml. And he's saying it has a pressure of what? 13 psi. So P equals 13. 13.0 psi. So remember, psi is just pounds per square inch. Fine. They said determine the pressure of the gas at a volume of 7.5 ml. Okay. So now they're telling you that this gas, it was at a first pressure of 13 psi when the volume was 15. Now they're saying that, okay, now the volume has now increase or decrease? The volume has now increased. So now we can name, let's say this is V1, P1, this meaning that was the initial, that's the first volume and pressure. So when the pressure was 13, the volume was 15. Now they're telling you that now the volume has reduced because now the volume is 7.5. 7.5. It used to be 15, now it's 7.5. So it has reduced. How do we know the new pressure? That's the question they're asking you. We don't know. So they want us to find. Okay. Now this is important. Someone will ask you, why is this important? Okay, I'll tell you why this is important. For example, if you've watched people inflate balloons and let them just float into the air, okay? I think we are going to look at an application very soon. Let me see if I have it. Okay, no, that's a different thing. We'll talk about that later. But this helps you to know the relationship between pressure and volume. So that if you're going into a space where you're going to reduce your pressure, you should know that if you have a gas trapped in anything, the gas is going to begin to expand. So that should guide us with many of the things we do from day to day. Okay. So let's look at it. We're trying to find the new pressure because you're saying that the pressure was 13 when the volume was 15. Now we have reduced the volume to 7.5. What will be the new pressure? So they are telling us, first of all, use the PV. Oh, sorry. First of all, use the PV graph. So they want us to tell the answer. A, they want you to tell the answer using the graph. So let's read the graph. A, they want us to use PV graph to give us the answer. So let's read the graph together. So from the graph, this is the PV graph. If you don't know what the PV graph is, this is the pressure. This is P. This is V, volume. Okay. So they want us to know. So initially they're saying that if the volume is 7.5, what will be the P? So go to volume. This is volume. Look for 7.5. This is 5. This is 10. Okay. So 7.5 will be somewhere here. Now trace 7.5 to the graph. Good. I know this is not very accurate. You can do a better job of tracing. Okay, I think that I was tracing and shifting to the left. So let me clean and trace it better. So that's how to. Oh no, what did I just do? Oh my, Gideon, what did you just? Everybody, I just cleaned everything. That was an accident. Wow. Okay, so I just wiped everything. So we're gonna do it all over again. So we're saying the solution. Wow, Gideon. Everybody, I'm sorry. Okay. Oh wow. I don't know what is happening to me. Okay, so we can do this. Everybody, let's do this. Okay. So solution. We know that the first pressure was 13 psi and the volume was 15. Now we want to find the new pressure. We don't know, something psi. When the volume was decreased, we reduced the volume to 7.5. Okay. Now they said we should use A. They said A, use the graph. Look at it here. A, use the PV graph. So this is the PV graph. This is the PV graph. B, this says use the 1 over P. versus V graph. So this is the 1 over P versus V graph. This is the P versus V graph. So let's try A. So A, I have my um, I have this graph. So we're going to look at, let's read this graph. So what is the volume? The volume is 7.5. So let's trace. This is 5. This is 10. 7.5 is somewhere here. I'm not doing a good job tracing. So I'm trusting that you're all going to do a better job. Trace it very well. We're trying to trace. So 7.5. If I'm tracing well, let's say 7.5 is somewhere here. Okay. So 7.5, it looks like I hit my graph. Let's say I hit my graph here and I go somewhere here. Okay. So the pressure, it looks like the pressure is somewhere there. So the pressure is somewhere around 25. Okay. So I'm going to say that when V equals 7.5 ml, P will be equal to 25 psi. Okay. And this was according to the PV graph. Okay. That means you're done with A. Good job. Good job. Now let's try B. Now B says that we should use B says that we should use B says we should use what? The 1 over P versus the V graph. So this is B. So everybody, let's try this. We're using the 1 over P versus V graph. So everybody, let's try this. So we have V of 7.5. So once again, this is 5. This is 10. So let's say 7.5 is somewhere here. Once again, I'm trusting that you will do a better job. So you do a better job of tracing than me. Okay, good. So we're saying that it's going to be somewhere. Look at me. It looks like it's going to be somewhere here. It looks like it's going to be somewhere around 0.4. Okay. So we are saying that when the volume is 7.5, the 1 over P is 0.04. So for B, we are saying that when V is equal to, for B, we are not done because we need to do some calculation. We are saying that when V is 7.5, 1 over P is equal to